Because I have no voice, I am going to videotape myself doing Unit 8, Section 2 notes so that you can listen to it today and learn it on your own. And then you'll be able to ask me questions one-on-one. So here we go. This is Section 2 notes, the mole-mass relationship. So our last class, we converted moles to particles and particles to moles. 1 mole equals 6.02 times 10 to the 23rd particles. And remember, particles can be atoms, molecules, formula units, or ions. Okay, today we're going to convert mass to moles and moles to mass. So our new conversion factor, our second conversion factor, is molar mass, which is what we learned how to do last time, equals 1 mole. So this is our second conversion factor that you're going to have to memorize. All right, so here we go. Go ahead and read the problem. All right, so that first couple sentences, there's really nothing in those first couple sentences except for this. We need the formula for whatever we're talking about. So it says, what is the mass of 9.45 moles of aluminum oxide? So mass, that's what we want. The given is moles. And since we're talking about aluminum oxide, we've got to have the chemical formula, which I'm not always going to give you. Okay? If you're dealing with mass, the first thing you should do is find the molar mass of the compound. So let's go ahead and find the molar mass of aluminum oxide. So we have 2 aluminums and 3 oxygens. Okay, so the first thing we did was we went ahead and found the molar mass because we're going to need that later. Okay, now let's go ahead and set up our picket fence. Okay, so the given goes in the upper left-hand quadrant. And then we want mass, but mass is labeled in grams. So what we want is grams. We need moles to cancel out, so it's going to go in the bottom. 1 mole. 1 always goes next to mole. And then our new conversion factor is 1 mole equals the molar mass. So what we just calculated goes on top. The labels mole cancels out. You multiply, divide by 1, which you don't have to do. You sig fig the answers. There are 3 sig figs in our given, so it means there's going to be 3 in our answer. So the answer is 964 grams. And if you wanted to sound really smart, you would add Al2O3. Okay, so do this in your calculator and make sure you can do it. All right, let's do the next one. All right, this says find the mass. The given is moles. So again, we have mass, so we need to find the molar mass of this crazy compound right here. We have 20 carbons and 42 hydrogens. Okay, so that's the molar mass, which we're going to need a little bit later. Let's go ahead and fill out our picket fence. Again, we want grams. which is mass. We need moles to cancel out. So 1 mole goes on the bottom, the molar mass goes on top. The label moles cancels out. Okay, be careful when you do your math. Scientific notation, put him in his own parentheses before you multiply. Also, there are 3 sig figs in the given, so we need 3 sig figs in the answer. And the answer would be 1.28 grams. And if you want to be really smart, C20H42. All right, let's do the next one. Go ahead and read it. Okay, again, in those first 2 sentences, there's just distractor sentences. The only thing we really care about is the formula for rust. And remember, I'm not always going to give you that. Okay, so this time it says how many moles. So that's what we want. We're given grams. Because we're given grams, let's go ahead and find the molar mass first. Okay, so that's the molar mass of rust that we're going to need later. Okay, let's set up our picket fence. So our given is grams. We want moles. So mole goes on top. We need grams to cancel out, so grams is going to go on the bottom. Okay, 1 always goes next to mole. The molar mass is going to go on the bottom next to grams. Grams cancel out. Let's go ahead and do the math. We're going to divide. If you look at the given, there are 3 sig figs, so our answer is going to have 3 sig figs. So 0.577 moles, and if you want to be really smart, Fe2O3. You don't have to put this 0. It is not significant. You can also put this into scientific notation. Okay, let's do the next one. Go ahead and read it. All right, this is find the number of moles. And we have grams. All right, in this example, we're talking about boron. Boron is only going to be B. It's not part of Hofbrinkel, so it's not B2. It's not in a compound, it's just boron. So the molar mass is 10.81. Okay, we're going to need that later, so set up your picket fence. Okay, so we want moles. He went on top. We need grams to cancel out. It does. Be careful when you put this in your calculator. Make sure you put the given in parentheses. Also, the given has 3 sig figs. That 0 is significant. So our answer needs 3. .0342 moles of boron. Or you can turn it into scientific notation. Either way. All right, now, up to this point, we've been converting from moles to particles or moles to mass. But what if I wanted to go from mass to particles or particles to mass? Okay, with no moles in the equation. It's going to be a 2-stepper. You have to convert to moles first before you can do this. So you have to go from mass to moles, and then moles to particles, or particles to moles, and then moles to mass. So it's going to be 2-steppers. So if you read the question, there is no mention of moles whatsoever. There's no mention of moles. then it's going to be a two-stepper. You might want to write that down. No mention of moles, it's going to be a two-stepper, okay? So it says how many molecules, that's what we want, and we're given grams. Okay, so we want molecules, which is a type of particle. We have grams, no mention of moles, two-stepper. Because I have grams, I know I'm going to need the molar mass of water eventually. So I'm going to go ahead and do that first. Okay, so there's the molar mass of water. I'm going to need that later. Okay, I'm going to go ahead and set up my two-stepper picket fence. All right, so the given goes in the same spot, only now in the two-stepper, our want gets to the very end of the row, okay? So we need to go from grams to moles, and then moles to molecules. Okay, so over here, we need grams to cancel out. Okay, so grams is gonna go on the bottom. We gotta get to moles, so moles goes on top. One always goes next to mole, and next to grams is gonna be the molar mass that we just figured out. Okay, so grams cancel out. Okay, now I have moles here. I need moles to cancel out, so he's going to go on the bottom. So 1 mole equals how many particles? Molecules are a type of particles. So this is going to be 6.02 times 10 to the 23rd. Moles cancel out. So my grams canceled out. My moles canceled out. So be careful when you multiply. Multiply on the top, Avogadro's number in parentheses, and then divide by 18.02. Sig figs have to match the given, so 3 in our answer. Okay, so the answer is 1.18 times 10 to the 24th molecules. And if I want to look really smart, molecules of H2O. Okay, let's do another one. What is the mass? That's what we want. Of 2.00 times 10 to the 22nd atoms. Again, there are no mention of moles. So that should be a red flag that it's a two-stepper. Okay, and since I want mass, I know I'm going to need molar mass. So look at carbon. Carbon is just C. It's not part of Hofbrinkel. So its molar mass is 12.01. All right, set up your two-step picket fence. All right, so we have atoms. We want mass, so I'm going to go ahead and put grams. All right, so for my first conversion, I need to get rid of atoms. And I got to get to mole. So 1 mole goes on top. Atoms is a type of particle, so Avogadro's number is going to go on the bottom. So atoms cancel out. Okay, now I need 1 mole to cancel out, so he's going to go on the bottom. And next to grams goes the molar mass. Okay, be careful. Your given needs to be in his own parentheses. Avogadro's number needs to be in his own parentheses. So carefully do the math. A given has 3 sig figs. These zeros count. So our answer has to have 3. Our label is grams, and if you want to be really smart, grams of carbon. Okay, you don't have to put this 0. You can also put it in scientific notation. I hope you enjoyed.